Find the maximum power which is transferred from the source, a given source, to a variable load ranging from 1 ohm to 3 ohm. So at first we have to find a value of resistance at the maximum power transfer, and then we have to check whether this resistance is at the right of this range, at the left of this range, or perhaps is within this range. So this resistance is at the maximum power transfer is 4 ohm, is here. Our range is at the left, which means that the minimum power transferred from a source, this source, is for the minimum value of resistance, a resistance of 1 ohm. And then very easily we may calculate a value of this power. This power is open circuit voltage divided by sum of resistances, square of this value multiplied by the value of resistance of 1 ohm. For this resistance, minimum power which is transferred from the source to a load is 144 watt. Now let me continue the same exemplary problem, but different range of load resistance from 5 ohm to 8 ohm. So now this range is located at the right side of this value for maximum power transfer, which means that the minimum power transferred from the source to the load is for the maximum resistance for resistance ranging from 5 to 8, for 8 ohm resistance. Same formula. If we set in this formula 8 ohm resistance, we will obtain 2 watt power transferred, minimum power transferred for resistance ranging from 5 to 8. And now let me continue. Let me assume that now maximum power transfer resistance is within this range. Let me assume that this range is from 3 ohm to 5 ohm. If so, we have to calculate in general a value of power for both resistances at the boundary values, and then we will find a resistance at which transferred power is the minimum one. So for a resistance of 3 ohm, we have 220 watt power transferred from source to a load, and for 5 ohm resistance we have power slightly greater, 222, which means that minimum power transferred from this source to load ranging from 3 ohm to 5 ohm is for 3 ohm resistance, and this power is 220 watt.